z1, z2 and z3 be three complex numbers such that magnitude of z1 minus z2 is 4 and magnitude of z1 minus z3 is 6 and magnitude of each of them is 8. Then we have to calculate minimum value of this particular expression. Let's think about this problem geometrically. Let's say complex number z1 is represented by point A in the organ plane. Complex number z2 is represented by point B in the organ plane. Complex number z3 is represented by point C in the organ plane. Then this data is basically same as the distance between points represented by complex numbers z1 and z2 is 4. That means distance between A and B is 4. This data is same as saying distance between AC is 6. What is meaning of this statement? That is magnitude of z1 minus 0 is equal to magnitude of z2 minus 0 is equal to magnitude of z3 minus 0 is equal to 8. That implies all the points represented by the complex number z1, z2, z3, the distance between them and origin is 8. Distance between ABC, points ABC and origin is 8. That means what? Points ABC lie on circle with center 0, 0, with center at origin and radius is equal to 8. So this data is given. So let's plot this particular data. Let me draw a circle. I have to take 3 points ABC such that they lie on this circle. Let me take point A here. Point A is represented by complex number Z1. Point B is represented by complex number Z2. This distance is 4. This is AB. This is 4 units. And point C is represented by complex number Z3, and the distance here, that is distance between A and C, that is 6 units. So I have triangle ABC like this. And what is the radius of this circle? Center is at origin. Let's use O to denote it, and radius of this circle is 8. This is 8. This is 8. Alright. And this is also 8. This is the given information. What I need to find is minimum value of this particular expression. What is minimum value for this expression? Let's understand this particular expression. Modulus of z1 minus alpha z2 plus alpha minus 1 into z3, where alpha belongs to real numbers. So if we change alpha, that means we get different complex numbers here, and out of all these complex numbers, whose magnitude will be least? This is the question. So we can rewrite this as magnitude of z1 minus alpha z2 plus alpha z3 minus z3. This is magnitude of z1 minus, if I take minus common, here it will be z3 plus alpha, let's take common, what we get? z2 minus z3. So this is one complex number. Think of it as another complex number. Alright, let me give the name w to it. I want to find the distance between z1 and w, and that too I need least distance. I need minimum value of this expression. Let's understand this complex number w. W is, we have taken it as z3 plus alpha times z2 minus z3. W is not one fixed complex number. If we change alpha, w is also changing. So from this statement, we understand that w minus z3 is nothing but alpha times z2 minus z3. That means, let me take these 2 points z2 and z3. Let's say this is BC. Okay. So w minus z3, That means this particular, think of this as a vector. It is, so one vector like a bar is lambda times b bar type. That means these two vectors are collinear. So w minus z3, this vector is collinear to the vector z2 minus z3. z2 minus z3 into alpha. So z2 minus z3 is vector like this. W minus z3. Okay, where should I take w? So that w minus z3, that vector will be collinear to z2 minus z3. So I'll take w here. So now w minus z3 will be in this direction. z2 minus z3 is in this direction. They are collinear. Or if I take w here, still w minus z3 would be w minus z3 would be like this. This is w minus z3, and z2 minus z3 would be like this. Still they are collinear. Collinear means what? The angle between them is either 0 degrees or 180 degrees. So that means I understand that w, z2, z3 must lie on same point, same line, must lie on same line. But w is not a fixed complex number, no? So if I keep changing alpha value, that means I'll be changing the position of w on the same line. Okay, so basically w is what? W is any complex number on the line joining z2 and z3. So now let's understand the question. What is question saying? I want to find, see this one, we want to minimize this. That means we need minimum distance between point representing complex number z1 and point representing complex number w. But w is a point on the line, right? So what is happening here? W is some point on the line joining B and C. W is a point on this line. Z1 is here. I want minimum distance between this particular point and this particular line. Minimum distance between point and line means it's perpendicular distance. So basically I need to find this length. This is the minimum length between point A and this line L. Let me call this line as L, line BC. That is what they are asking. Find AD length. That is the given question. But how to find AD length? Okay, so to find AD length, let me take this angle as theta. This side length is 4, right? So what will be this AD length now? If this particular angle is theta, that would be, see, this is 4 cos theta, right? This would be 4 sin theta. So AD length, that is 4 sin theta. So let me write here, AD length is 4 sin theta. So to solve this problem, all I need to do is find this theta. How to get theta? Now when I look at this particular circle, take the chord AC. Take this chord AC. Take this chord. What angle it is subtending at this point B? What is this angle? It is subtending at a point on the circumference. That is theta, right? This angle is theta. So we have studied this particular property that if there is a circle, if there is a chord, if it subtends an angle theta at any point on the circumference, what angle it should subtend at the center? The same chord, it would subtend angle 2 theta at the center. Alright. So that means when I take this AC chord, it subtend theta at B, right? But B is a point on the circumference. So what angle this AC chord should subtending at the center? This angle must be 2 theta. This angle is 2 theta. Okay. Now consider this triangle OAC. Consider triangle OAC. Now I'll draw a line perpendicular from center to this chord. I'll draw a line like this. This OF line divides this triangle OAC into two congruent triangles, right? So what would be this particular angle? This full angle is 2 theta. So this should be theta and this should be theta. And what about FC length? AC length is 6 units. So F2C, this length would be 3 units. And A to F length would be 3 units. Now let me consider triangle OFC. Consider triangle OFC. Now from this directly we can see sine theta, that is opposite, that is 3 divided by hypotenuse. Since we found out sine theta as 3 by 8, this AD distance would be 4 sine theta, right? That is 4 into 3 by 8. That is 3 by 2. That means the shortest distance between point A and the line BC, that is 3 by 2. That is what is asked in the question. So the shortest distance is 3 by 2. It is less than 5 by 2, 7 by 2, 9 by 2. So that would be our answers.